Hi everyone, welcome to my channel. Today we will create logistic regression model using diabetes data from Kaggle. You will find link to the dataset in the description of this video. We are creating a Jupyter notebook, Logistic Regression Volume 1 and giving title as Logistic Regression with Diabetes Dataset. In this Jupyter notebook, we are going to cover data acquisition, data preparation and manipulation, exploratory data analysis, data modeling, logistic regression, and evaluation of model. Firstly, we will import desired libraries such as pandas as PD, numpys as np, matplotlib as plt, and seaborn as sns. Under data acquisition, we will read the dataset for diabetes, which we downloaded from Kaggle. The link for the dataset is in the description of this video. We are reading the diabetes dataset file into data frame data_df using pandas function read CSV. Now let's explore the dataset, and you can see that the dataset contains 76 rows and 9 columns. Let's see what are the values in each columns. So I am doing data frame head function to read first 5 rows and then run info function to describe the data frame structure. We can see the details of all 9 columns where all the column data type is integer except BMI and diabetes. Pedigree function as float or decimal numbers. Also, all the columns have 768 rows with not null values. We can confirm that our dataset has no null values and contains only numerical values. Next, we are checking the unique value in the data frame using unique function. And now you can see the column outcome has only 2 unique values. If you see the row minimum, 4th row to be precise, columns like glucose, blood pressure, skin thickness, insulins and BMI has value as 0. Hence we will replace the 0 value to the respective mean value. We are using is_in and sum function to find count of 0 values in each column. Now we will move to step 2, that is data preparation and manipulation. Here we will replace all the 0 values in glucose, blood pressure, skin thickness, insulin and BMI columns with their respective mean values. The pregnancy values can be 0, hence we are not updating any data in this column. But we are updating all the values of pregnancy greater than 1 to 1. So now the pregnancy column has only 2 values, 0 or 1. 0 means not pregnant and 1 means being pregnant already. Now we will move to step 3, exploratory data analysis. Here we will create heat map that shows correlation between the columns to understand the correlation between them. As you can see my screen, with data in the correlation table and heat map, it is clear that there is strong correlation between BMI and skin thickness. And the column outcome is correlated with glucose and BMI. There is no reverse correlation between outcome and other independent variables. We can observe some more correlation between age and blood pressure and also insulin and glucose. Further, let's explore more insights the dataset has. For that, we are creating 3 scatter plots with BMI and skin thickness, blood pressure and age, and glucose and insulin, with BMI, blood pressure and glucose in x-axis and skin thickness, age and insulin in y-axis. After visualizing the 3 scatter plot, we found strong relationship between 2 independent variables, BMI and skin thickness. Again, compared to skin thickness, BMI has stronger relationship with the outcome or the predicted value. Hence, we are dropping skin thickness to avoid any kind of multicollinearity. Using drop function and axis value as 1, we are dropping column skin thickness. Now let's check BMI and glucose, which are the most influencing variable in current situation. For that, we are plotting two box plot to check outliers in dataset for column glucose and BMI. You can see there is no outliers for glucose, but for BMI we have some outliers. Now to remove outliers, we are calculating IQR or interquartile range for BMI. For that, we are creating variable Q1 and Q3 to assign quartile value using quartile function 0.25 and 0.75 respectively. Then IQR value is difference between Q3 and Q1. We are calculating two limits for outliers, one is lower outlier and next is higher outlier. We are now calculating total number of outliers in BMI, which value doesn't fall between the low and highest limit of outliers. We have around 8 count of outliers which we are removing from the data frame. Now we will move to next step, that is data modeling, logistic regression and model evaluation. For that, we are importing required libraries from sklearn model selection, import train test split, and from sklearn linear model, we import logistic regression. We will now data model into two variables x and y, with y as predicted variable with value of column outcome, and variable x contains pregnancies, glucose, blood pressure, insulin, BMI, diabetes pedigree function, and age. Further, we will split the variable into x train, x test, y train, y test using train test split function with test size of 30% and quickly check the value of the new created variables. After we have checked all the variables data, now we create a logistic regression model and name it as model_LR. Then fit our model using fit function and variable x train and y train. We will then create a new variable ypred where we will assign all the predicted variables using predict function and x text column. Now let's explore the value in ypred or our predicted values. Now, after successfully creating logistic regression model, we will evaluate our model using classification report. For that, we will import classification report from sklearn metrics library. And now we use classification report function and variable ytest and ypred. The output gives us value of precision, recall, F1 score and accuracy. Now let's see what all of these values mean and tell us about our model. Precision. Precision measures the proportion of the positive predictions among all the predictions. In this case, the precision of diabetes is 0.7 or 70% of the predicted were actually diabetic. Recall. Recall measures the proportion of true positive predictors among all actual positive in dataset. In this case, the recall value is 0.57 or 57%. F1 score. F1 score is the harmonic mean of precision and recall. It provides a single score that balances both precision and recall. The F1 score of all diabetic is 0.63 or 63%. Accuracy. Accuracy is one metric for evaluating the fraction of prediction of our model got right. Here the accuracy of our model is 0.77 or 77%. Now let's visualize and plot logistic regression graph with all 6 variables using matplotlib and regplot function. In my screen, you can now see and visualize the 6 plot with respect to our predicted value outcome for all our 6 variables. If you like this video, don't forget to hit like, share and subscribe so that you don't miss out on our new and exciting videos. So stay tuned.